Test, test, test. Beep, 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 boop. Oh, why did that happen? I didn't mean to time you out. How'd I do that? SRP. I don't know how I muted you. I think I accidentally clicked something. I'm sorry. I can't untime out. All right, I think we might be back.
Okay.
So we were using a really cool new camera, really high quality camera that is fantastic and works great, and we would be much better quality if it didn't decide to break my laptop. So, you know, things are what things are. But I think we're back. Stream is good. Things are working. We can see the globular cluster we have been talking about. Let's crop this down so we can zoom in a bit. Lovely. Yeah, look at that. Look at that. We're back. I'm sorry, guys. That was really frustrating. But we should be back. We should be back and all good. Let me pull up this software. That will allow me to
Hey, there we go. Yeah.
That's better. Fantastic. Alrighty. So, we're back.
We're back.
Can you guys hear everything? Mic's all good? We should be fine. We should be fine.
There we
go. This is a professional broadcast.
Yes.
Razer, if you're watching, I need a better laptop in order to do this better. I'm the only one in the world trying to do this fully off-grid, and I need your help. So, or any other laptop brand. It'd be very cool. Let's just do that a bit. Perfect.
Amazing. We are. I'm proud of us, Alistair. We are in the middle of a battle of man versus nature, man versus technology,
Man versus machine.
Man versus machine, man versus misfortune, and we're gonna come out on top.
Someone's coming out, that's for sure.
Heyo.
Be a little laggy or something. I think we're good. I think we're good. Alrighty. Yes. Imagine the tiny headed kingdom made a bear wearing a Minecraft outfit. That would be really cool. I love that bear. I didn't bring Micro Ted with me. I've got this little tiny bear with a huge body and a tiny little head. But he is a bit large to bring on my adventures, so that'd be cool. So yes, reintroduction, in case you are just rejoining us. Hello, welcome to the middle of a field. I'm in the middle of a national park in somewhere rural in the East Coast. Actually, no, I could say. We're in Virginia at the moment, and I'm here with my friend Anthony Lund. He is an incredibly qualified physicist, writer, director, producer, a whole bunch of awesome things. He's worked on a show called Through the Wormhole that you might have heard of. I love a rare Eret sighting. Thank you, Cecily. Yes, he worked on writer, director, and producer on a show called Through the Wormhole with Morgan Freeman, and you were nominated for Emmys in that show. Very fucking cool.
Yeah.
That's it's in TV. It's like it's like a TV Oscar kind of.
Yeah, that's literally what it is. It's TV Oscar, and I lost all 3 times to Anthony Bourdain.
Wait, the same guy all 3 times?
Yeah, same guy all 3 times.
Damn.
But you know,
Damn.
If you're lose to someone, lose to the best.
Bourdain.
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 And you know,
Hey, at least it's another Anthony, right?
exactly, yeah. You know, it's like may the best Anthony win. You know, there was one year. There was one year that Neil Tyson was also nominated.
Oh yeah, Neil deGrasse Tyson.
Yep. And he's I guess I would say like a colleague of mine because I run into him all the time at all the little functions for science media. And I remember I ran into right after both of us got nominated. It was right around Comic-Con that year, and I ran into him in a bathroom at Comic-Con, and we both we're both at a urinal, and I'm like looking over, like, oh, Neil. He's like, oh, hello, Tony, and we're like, you know, at a urinal, and I'm like, oh, by the way, you know, congratulations on your Emmy nomination, and he.
At the urinal.
And mid-urinal, he's like, oh, well, you know, thank you. And he didn't, like, I don't think he knew, because he didn't say, like, and congratulations to you or anything. But he just said, oh, yes, well, you know, I hope the Emmy people win the Emmy Awards. But this is his way of saying he's, like, he kind of doesn't care.
Fair enough. He's done well. He's done well for himself. Thank you so much, Paprika. 62 months is crazy, and Sassily, 58 months. You're nuts. So before the stream cut out, we were talking about, so what we've got here is M13, which is a globular cluster. And in the grand scheme of the universe, you were saying how over the grand scheme of the universe, everything kind of averages out.
Yeah,
it's pretty
very flat.
It's pretty flat. And I was saying how so there's these like random areas just from the little variations where you've got these like peaks and concentrations of matter, like this. This is a live feed again. Like this is live. This is up in the sky right now. We can see it. And what we can do is any moment now, well, any moment, we can do it literally whenever. We can find another object to look at, or another galaxy, a nebula or something, and we can just scan right over, and you guys can be like, let's look at a galaxy, and we can find a galaxy to look at. So,
and I might add too, you know, stick around on the stream, because we are going to attempt to resolve the Andromeda galaxy tonight.
That's the closest galaxy to us.
Yeah. It's very difficult to do that with a telescope because it's very far away. We're going to make an attempt, and if we resolve it, it'll just be incredible.
Yes. This telescope's here just for looks. It's not doing much right now. I mean, we can look through it. You can't look through it. It's not for you.
Watch me go to the telescope, like, oh my God, what is that? There's like aliens up there. They're fighting. There's a space, but oh, I just saw a laser. There's explosions.
You wish you could see through the telescope. What the fuck? Just look. Shh. It works. You can see all the different stars on here. It's really cool.
Yeah. So you know, with a cluster like this,
yes.
What starts these in motion happened at 13.8 billion years ago.
That's a long time.
Very long time in the early universe. And then it led to these just little tiny differences in the amount of hydrogen gas floating around that is over here versus over there. Now, over
that's like
billion
just
years,
hydrogen?
Yeah, in the earliest days of the universe, it's just hydrogen. Now, granted, there's also some helium, and there's also a little bit of lithium if you say, okay, it's a special flavor of lithium.
Sure.
But for the most part, you can think of it as being dominated by hydrogen and some helium too. A little bit of lithium. Now, what's amazing about that is all the other heavier stuff doesn't exist yet. All the heavier stuff doesn't
exist.
Cooked. Yeah, it hasn't. Nature hasn't unlocked that crafting recipe yet.
We are using Minecraft analogies, my friends.
We're just gonna have to.
It works.
It works.
It's a robust game. We used it to describe how noise does terrain generation of mountains and troughs in the same way that the randomness of the universe makes globular clusters and galaxies and vast nothingness, but it all kind of averages out. And now we're using it for this.
Yeah. And what's going to happen is the way that nature unlocks that crafting recipe is that all of that hydrogen gas, eventually it starts coming together under gravity, and it gets denser and denser and denser until it starts forming stars. Those stars are going to cook it.
This is a lot of stars. All of those dots is a sun, like our sun. Some are bigger than our sun. It's really cool.
Yes. They become big fusion generators.
Yeah.
So they're fusion power plants that all that hydrogen starts fusing together under the enormous pressure of gravity. And when two hydrogen atoms fuse together, they release energy. That energy is what props the star open and prevents it from collapsing indefinitely into a black hole.
So the hydrogen turns into helium, and that produces energy?
Mm-hmm. Yeah.
Okay.
In fact,
and that's how suns work. That's what fusion is, and that's how helium exists. And then heliums can like crush together, and they make other elements.
They can, yeah.
And those crush together, and those make other elements.
Yep, that's it.
And that's how every element exists.
Yes.
By just being crushed in the center of stars.
I'm gonna add a little asterisk.
Yes.
At the end of the periodic table, when you get into the berkelium and francium and einsteinium and stuff,
we made those.
We made those
ones,
and they lasted for like a hundredth of a percent of the length of a fart. They were just like gone. So
the length of a fart.
The length of a fart.
But like all the carbon that's makes us, the iron in our blood, the carbon that makes the plants and everything.
Yeah.
That was all
cooked in those guys.
At some point in the very center of a star.
Not even just in the center, like throughout its body, because the heavier elements, especially the metals, those are created when you have supernova explosions.
Yes.
So normal fusion process is going to oh man, my astrophysicist colleagues are going to kill me if I get this wrong. So let's speak heuristically. So
yes.
For the most part, it's just hydrogen turning into helium. Other things happen depending on the properties of that star.
I saw a graph of all the elements in the universe. It's like 75% hydrogen and then like 25% helium, but 24 point minuscule amount helium, and then every other element that ever possibly exists is in that fraction of 1%. Mm-hmm. And then I saw what I find, at least, to be a funny comparison, which is, well, 75% hydrogen, 25% helium. We live in a binary world. There is only hydrogen and helium. There is nothing else. Nothing else is allowed to exist. It can only be hydrogen and helium.
Ignore the ends of the Gaussian curve. That does not exist. Periodic table, as the dear Lord intended, is just hydrogen. Obviously, boy atom, because more important than girly helium. That's it. That's just it.
It makes your voice go up.
It does. See, the Bible predicted this, Alistair.
The Bible?
The Bible predicted this. Helium makes your voice goes up, therefore girlium. Let me ask you a question, though.
Yes.
Why do you think it's called helium?
I have no idea.
It was named after Helios, the Greek god of the sun.
Oh, the sun.
Yeah.
Ooh.
And it was
That's cool.
It was discovered more recently than you might imagine. This was only like maybe about 150 years ago. And the way it was discovered was a German physicist. Oh mein Gott, I'm gonna put Franzenhofer, something like that.
And that sounds like a German
Yeah.
scientist name. I believe you.
I'm just gonna muffle and say like Franzenhofer. So he's looking at the emissions of our sun.
Yes.
He's looking at the different spectrum of light that come off of it. And when you have a really good prism, like we've all seen this where sunlight goes through a prism and it splits and you see a rainbow. Well, if you have a really good prism and you have a good experiment, you'll notice that in the kind of reddish orange area, there is a little dark band, little tiny thing where it's like no light is being emitted. And the only way that that's possible is if there is atoms in the sun that are absorbing that specific frequency of light.
So if you had like a little triangle of glass or something and you have it at the sun and it's picking up the light, you could, very, very specifically, there'd be like a little shaded patch.
Yeah, so you get that rainbow.
Yeah.
Beautiful spectrum. You know all that's. we're very pro spectrums and rainbows here. So.
What are you talking about? Yes.
Sorry,
go on.
Oh, I was gonna say. So you take that rainbow spectrum, and if you have a really good experiment, you can make a quite a large one.
Yeah.
And right around. Let me reverse it. Okay. So we're red to blue, and then right around where it sort of gets reddish orange. It's just missing. There's a black line because ain't no light being emitted in that spectrum because it's being absorbed by
greedy
these
helium,
mysterious atoms that we now know are it's helium.
Greedy helium eating all my light. I want to see if we can.
By the way, I got a text message once from one of my students where she was just over the moon. And she texted me, she's like, I'm watching my boyfriend play the Spider-Man video game. And, like, he has to do a little mini game with Franzenhofer lines. And I'm like, this is amazing. She's like, I know what those are. all exclamation marks. I'm like, I have taught you well.
All right. So I am stopping the capture of M13. I'm going to see if we can look at something else. The astrophage. You saw Project Hail Mary, right? Oh, you have the book. I've seen you have the book. Of course you know. That's a good movie. If you haven't seen it, we're going to save Andromeda till the end. Let's see if we can get a cool nebula. Which of these will look good? Let's see if we go to... All right, well, that's not working. The Fireworks Galaxy. What's that? All right, let's see if this works. It's going to...
If the Helix Nebula is observable tonight too, that's another amazing thing to look at.
The Helix Nebula, what's that?
It's a planetary nebula, and it's been referred to...
What is a planetary nebula?
Happy you asked. So a planetary nebula it's this weird name that stuck, and like most things in physics, it comes from we don't know what the hell it is. And early astronomers that were looking at these things, they're like, "Oh, this looks kind of like a planet."
Yeah.
So it's a planet.
All right.
But it's not.
Sure.
So when you have stars that are very similar in mass and size to our sun, eventually over time, they get bigger and bigger and bigger. And the reason why they get bigger is because they're losing a lot of their fuel to sustain this fusion reaction. And so they lose mass. And as they lose mass, there's less gravity containing the star. So they get bigger because there isn't enough gravity to hang on to it. And eventually you reach this point where outside of the core of the star, all of that hydrogen and helium...
Move the camera a little closer.
That hydrogen helium starts to just drift off. It's freed from the star, And it's now just hot gas that is expanding out beyond the star. And this goes on for a really, really long time. These are very energetic, it's a very energetic gas. And eventually these things can be like light years across.
Yeah.
But because it was this very non-violent, just sort of sloughing off the surface, it expands quite uniformly in a spherical direction.
Yeah.
Now there's little tiny distortions and deviations.
So Plenty and Nebula are like they were stars?
Yeah.
Okay.
Yeah.
They're just like stars that just go.
Yeah. There's like
kaboom.
no more skin. I don't want my skin anymore.
Can we ask space-related questions? Please ask space-related questions.
Ooh, yes,
that's
please.
what he's here for. He's a professional. He knows his stuff.
I do. This is. Oh, by the way, you know what? So, I'm a physicist that kind of found my way into Hollywood, which was very fun. But how I.
We also happen to go to the same university by chance, which is pretty cool.
Yep. We sure did.
But you actually graduated. I dropped out to play Minecraft.
To be. to be fair though, so I double majored in film directing and physics.
Yes.
And at our school, as a very prestigious film school, and the dream of every film student is to drop out, because if you drop out of the film school, it means you're like really, really, really good. So technically, I kind of failed the film school part of my degrees by not dropping out. If it makes you feel any better.
Says the Emmy nominee. I kind of failed film school, nominated for Emmys.
Yeah, it came out okay in the end.
Yeah.
So
I'd say so.
You know, but I digress. The little story I was going to tell is how I got my first job in the entertainment industry as an associate producer on the Morgan Freeman show. Was I met with the showrunner and the executive producer of the production company that was making it at a Starbucks, and I explained to him how general relativity worked and how black holes work using one of those little napkins that you get at Starbucks.
Yeah.
That and like a coffee straw to model the physics of a wormhole. And it was like, yeah, okay, all right, cool. You're like, yeah, you're hired. I'm like, oh. Awesome.
You got the job. Let's see if we can get this one. So, NGC. I forget the name of this. I probably should have paid more attention. It just looked cool in the preview image. So we're going to see if the...
I think it was the fireworks galaxy.
One of those. Could someone look up NGC 6888? This is a professional show. I'm so professional. We had hear a lot about super Earths and how it's similar to ours, except the water is frozen or the air is unbreathable. Is there a chance we would see people sent there in our lifetimes? And space is so vast, why do you think we haven't found one exactly like ours yet? That is a good question.
Oh, God, I have so much to say. Okay, first off, unfortunately, in our lifetime, no. Interstellar human travel is very, very difficult. For a variety of reasons that we can get into.
Things are very, very, very far away.
Yeah.
Like, very far away.
And there's a handful of ideas that have been proposed on how maybe we would do it. But let me circle back to that and answer the second part of your question, which is, like, how do we find more of these super Earths? I
have things to say about super Earths as well, but I will leave them
marvelous,
to you.
Marvelous. This is discovering exoplanets is something that happened very recently. We've always suspected that they exist, but we've never been able to observe them directly because they're so tiny compared to stars, and they're far away. So, you need like a telescope the size of planet Earth to like observe them directly. So we never really saw them until about 15 years ago, about 20 years ago.
Really? That recent?
Yeah, that recent.
We never knew like planets outside. I mean, we could guess that planets existed outside our solar system, but we didn't know for sure until like 15, 20 years ago.
Yep. Isn't that amazing?
That's crazy.
Yeah, and I'll show you guys how we did it. So,
thank you, Athos. Athos, you're very cool.
All right. So, chat, you're looking at a star. Oh, it's bright, but it's very distant and it's far away, and you see this light. Now, I'm gonna grab a little twig here. So, what happens is the planets that are orbiting that star are going to the leaf off of this. So, the planet is going to orbit that star, boop, and it's going to change the brightness of that star by a tiny, tiny amount. So, see if you catch it. It's very, very, very faint, but you see that. Boop. Boop. Yeah.
Yeah.
So what we do is we built this amazing spacecraft called Kepler.
Yeah.
And what Kepler does is it is just a big ass camera, and it sits and it is looking at a tiny patch of space
In space.
at a tiny group of stars. And it's just measuring the light coming off the stars to very, 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 very fine degree. And what it's looking for is that. So I have this little twig in my hand, and I'm just moving it past like a planet orbiting. Whoop, and you see that little dimming.
So in order to even see them, they need to pass directly in front of the sun.
Yes.
Okay, but that's only going to be like a tiny proportion of them.
Well, if we observe in the right direction at the right objects, the hope is to be observing on the
It's like we need to see them right on the edge.
Yeah. So the all solar systems are going to have a type of axial tilt, meaning they're like think of them as like a disk. Luckily, the majority of them line up with the way that the Milky Way galaxy is oriented, but not all. So we just have to look at the right ones, and based off of that little dimming, we can work out the physics of what these exoplanets are. And it's been an absolute explosion in discovery of figuring out we can roughly compute the masses of these, and as we continue to like learn how to work with the data better from Kepler, we can start to look at little diffractions of light across the edges of these planets and get a little bit of hint of like what the atmosphere might be made of. And that is so exciting. And that's where we find these like super Earths.
So an interesting thing about super Earths is they're called super Earths because they're like very similar to our planet Earth. We think they're probably in what's called the Goldilocks zone away from their star, which means they are not too hot, not too cold. So they could have liquid water on their surface. But because of the way we find them, they have to be big because they've got to block out enough sunlight for us to be able to detect them. However, what I think is interesting about these super Earths is because they are so big, because they are so big, the gravity on those planets might be too large for any intelligent life that lives there to ever get to orbit.
Perhaps, yeah.
Because so Earth's pretty small,
yeah.
planetarily speaking. And the maths just kind of works out. It's really expensive, but we can put a big mass on a rocket, put enough fuel behind it, and the weight of the fuel, plus the weight of the rocket, plus the weight of the payload, still makes sense to be able to get off the planet. But if gravity on Earth was a bit stronger, maybe, unless you found some super efficient fuel, maybe you wouldn't be able to get off the planet at all.
Yeah, you would have to. You would have to find really good propulsion source.
And you would need to be going fast enough to be able to orbit a planet that big as well, because you need to be going even faster than you would need to orbit here, because orbiting is not like, oh boy, we're suddenly just going in a big circle now. Orbiting is just like you're falling towards the planet Earth, but you're moving sideways fast enough that when you've moved sideways, you're not going to hit the Earth, because the Earth's always pulling you down.
It's technically falling with style.
Yes.
Yeah, that's it. You're falling.
By the way, this is currently doing a long exposure of NGC 6888. Wait, I can click the information button here. So what you should slowly start to see in the middle right here, let me see if I can click this. Oh, hello? Crescent Nebula. Well, that's what it's supposed to look like. I don't know why it's lagged. Hello?
Wait.
It is resolving.
Okay.
But it's slowly collecting. Let me... Oh, I just needed to turn my phone on properly. So Crescent Nebula, also known as NGC 6888, is an emission nebula in the constellation Cygnus, about 5,000 light years away from Earth. Discovered in 1792. Very cool. All right, so that's what we're looking at. And it'll...
Oh, you can see it. You can see it.
Yeah, you can see it. There's a little bit of pink right here. And as time goes on, it will get better and better. So hopefully, within like 5-10 minutes, because this has been going for like 2.5 minutes, but in 5-10 minutes, it should look a lot better. And then the longer we go, the more light the telescope can collect, and the even better it'll be going. That reminds me, I need to go check the battery on the satellite internet.
Amazing.
Let me be right back.
Okay, I will talk to chat. I honestly got to say, this is the first time I've worked with this telescope, and I love it, because all of my experiences with telescopes have been doing them kind of the hard way. That it makes you feel cool about yourself when you're using like lasers and sighting scopes. Like telescopes use the same red dot scopes that you see on like rifles and firearms.
We're on 52%. We're good. Like this, you have to like look through the eyepiece and move it manually, and you need to know exactly where you're looking, and it's got a little laser on it where it's like, all right, let me align it to where I'm trying to go. And then the Earth is rotating constantly, so you need to keep on adjusting it manually. And it's a pain in the butt.
This is incredible, though.
This telescope does it all automatically. It's great. They haven't sponsored me yet, so...
C-Star, if you're watching.
C-Star, if you're watching. I need to email them. That'd be cool.
Yeah.
But yes, Super Earths, incredible. We're probably not going to get to them, or we're not. The closest star is called Proxima Centauri. Proxima Centauri, and that's like 4 or 5 light years away.
Yeah, about 4.
And that's the speed of light. So a light year is how fast light can travel in a year, or how far light can travel in 1 year. And I have to look up the specifics on this. But I'm trying to find a way to put it into context, because the speed of light is incomprehensibly fast.
Yeah. You can go around, if you had a little laser pointer, and it had just it had a magic ability where it could just curve, and it could follow the curvature of the Earth, like that. Ooh, we have enough ambient humidity that...
Yeah.
I don't know if it shows up on stream.
It won't show up on stream.
But yeah, I'm seeing the direct beam. Woo. So suppose that laser pointer could curve around the Earth. Well, you press it, and then in 1 second, it's gone all the way around the Earth 4 times. Just like,
In 1 second, it goes around 4 times.
yeah.
Damn, that's fast.
Yeah. It's 3 times 10 to the 8 meters per second.
That's a big number.
So that'd be 3 followed by 8 zeros meters every second.
I mean, I would try and translate that for the Americans, but it probably wouldn't help. That's a number that's too large for comprehension.
I refuse. Alistair, the one hipster thing I do is I get all my weather apps and anything that tells me the weather or temperature is all set at Celsius.
Yeah! Celsius is better. Thank you, sir. Yeah.
My pleasure, sir. My pleasure. I will carry on, and I will keep the torch of Celsius alive in this country.
Okay, we've got a little ad break going on right now. That's automatic. I forgot to turn those off. Oops. But if you are subscribed, you will not have an ad break right now. Very cool.
Fantastic.
Alrighty, things are going well. The stream's going good. Things are going good. Let me move the camera a little bit.
I am so sad that the Sony camera is like borked the computer. And I wonder, I have no idea if it is a power thing or an HDMI thing.
I do not know either.
But also, don't care right now. Because the quality of the production camera is not what makes this thing what it is. It's all these amazing people with all these amazing people in chat that joined us. Like that's what makes this special.
Sorry, I pointed that down a little bit.
Hello. Premium subscribers.
Thank you for subscribing, everyone, because you help me do things like this. And I plan to do this around the world just a little bit. I'm going to India and I'm going to Australia next month. So we'll maybe be doing some stargazing there. That would be very cool. And if I can't do stargazing there, then we'll just do cool streams. But it would be really cool if I could do stargazing there and at least see the moon there, because if you're in the southern hemisphere, the moon is upside down. Which I think is pretty cool.
The people in Oz would say, no, it's the right way up, mate. Oh, your moon's upside down, mate. What are you going on about?
All right. Framing is good.
Fantastic.
Love chilling and hearing talk about stars. It's so good. We've had some minor tech issues, but it's all right. We're getting better at it.
We embrace the scuff.
Embrace this goof.
Yeah, I wonder.
Did the clouds come in? I'm not seeing many stars right now.
You know,
we could go red light mode.
It's hard. It's hard to tell because we do have atmospheric condensation that is probably mostly ground level.
All right, we're gonna go red light mode. So for those who don't know, hello.
Hello. Welcome to Stargazing After Dark.
I was stepping on all my stuff. That's not ideal.
We've entered red light mode for premium subscribers.
What do you mean by that?
I don't know. In my travels and experiences, wherever there's red light, you're going to have a good time. Your wallet is going to be significantly emptier, but...
Okay, so we can't see much right now, but red light mode means we can maintain our night vision a little bit. It's a little cloudy, but I can see the Dig Bipper was over there. Yes, things are getting a little clearer. Hello.
Hello.
Yeah, there are some clouds. I'm just glad we're able to see anything at all, honestly. All right, it's getting better. It's getting better. I will... The Big Dipper? The Big Dipper. Okay, I'm going to put the big light back on so you guys can actually see us.
Yeah, you know. It does look like a little bit of cloud cover came in, but
Yeah, I can still see some stars.
yeah,
That's good. The long exposure is collecting some stuff, so it can see some things. All right, let me go turn the light back on so you can see us.
You know, wow, that is so funny.
What?
It is so funny how quickly it robs you of human night vision.
Oh, like having the
Turning
big
on
light on?
the production light, yeah, because human night vision is pretty good.
Ugh.
Like if we were out here without any source of light, we would have a incredible show.
Yeah.
And almost to the point where you could read like a book.
Yes.
Like just about at that threshold. Like the stars, if you can go out stargazing where there's low light pollution, I cannot encourage you enough to take the opportunity to go do that. You feel better, you feel connected to the universe, you feel connected to nature, and
Yes.
it will surprise you. Just two things will always take your breath away. One, just how many of them are that you can see with your naked eye, and two, how colorful they are.
Colorful?
Yes.
Like the stars?
Yes.
Or just...
Stars. Yeah.
Cool.
Yeah. There's blue ones, there's red ones, there's yellow ones. There's some are like kind of a little green.
Interesting.
Yeah. They're very colorful. And that is literally their color. It's not an optical illusion. Stars have color. You know it'd be a really fun poll question to ask chat, Alistair?
What?
What color is the sun? But they might cheat. They might cheat and look it up, but it would be great to see what people respond with, like with no cheating. But yeah.
Oh, I know the answer to that question.
Yeah. What color
is the sun, chat? What do you think? What do you think the color of the sun is?
Now, okay, let me also add a caveat, because if somebody says, well, it's all colors, they're technically right, but what is the dominant single color of the sun? The sun does pump out
Superman
lights.
calls it yellow. Orange? White? The way it's orange, yellow, of course. And it's got a smiley face and sunglasses.
Yeah. and it's filled with vitamin D. The
Yes.
the sugary orange beverage told me so.
Sunny D. It's yellow in the corner of my coloring. Yeah. It's white though, isn't it?
It has a dominant color, and that's what we're going to talk about.
Oh, okay.
Yes. So
wait. Green?
Nope.
Fuck.
Nope.
Okay. Tell me.
Okay.
Please, educate us.
It's blue.
Blue?
Yeah.
What do you mean, blue?
The sun's
sun
dominant
can't
color.
be blue.
It's blue. It's blue.
How?
Okay, so, all right, you've worked with cameras.
Yes.
Chat maybe has worked with cameras before, or you've bought LED lights, and you'll notice this funny little number where it'll say the LED bulb or your camera setting will say 3500K, or it'll say, 3600K, I think.
Yeah.
Or it'll say 5500K.
That means like Kelvin.
Kelvin. Kelvin is a measurement of temperature.
Yes.
Kelvin is just Celsius, but at 0 Kelvin is absolute zero. That is the coldest that anything can ever get in the universe. Really crazy physics happen at 0 Kelvin. We'll save that story for another time. But the temperature of the sun is 5500 Kelvin, which is very hot. And when you do the nuclear physics of the sun that results in this temperature, you get a spectrum of light with its peak at 5,500 Kelvin, which is, in human vision terms, is blue light. So when you set your when you get a light bulb,
Yes.
that is 5,500 K, it is tuned to the blue of the sun. So that would be called like a daylight bulb.
And is that like through atmosphere, or if you're in space, would it just be a bright, like whitish, bluish?
Yep. If you're in space, very, very, very white, bright star. But if you start filtering it out, it's blue.
And does it just seem more yellow because the sky is blue, and so it's blue because it's refracting all the blue through the atmosphere, and because of that, it filters out the blue from the sun and makes it look like yellow-orange?
Bingo. Yeah. So yes,
Yeah!
yes.
Stuff.
Yeah, you did. Yeah, you got it. Although I'm going to give you a little bit of a technical correction because it's not that it's refracting, it's scattering. So we call this Rayleigh scattering, and it's the sun is just pumping out like many frequencies of light, most of which is blue. But the more blue your light, the more energetic it is. And the more energetic the light, the more prone it is to bounce off of stuff.
Yeah.
Think like you can use sound as an analogy. You're in your home, car drives by that's really pumping loud music.
Sure.
What do you hear, the treble or the bass?
Bass.
Yeah, light is no different. So treble light, higher frequency light, bounces all over stuff. But lower frequency stuff like infrared, really bassy stuff, microwaves, that just goes right through everything. So blue light is scattering off of all the
blue's higher
atoms of air.
frequency and red is lower frequency.
Correct.
So we see more red because the higher frequency stuff gets filtered out by the atmosphere.
Yeah, it bounces off all of the particles of air that are in our atmosphere. Yeah.
That's cool. I didn't know that.
Yeah. And so because all that blue light has been scattered from Earth, on our perspective, the sun takes on kind of a yellow tint.
Yeah.
But, is blue.
Well, now you can say to someone, did you know the sun is blue? And they go, no, it's not. And then you could link to a clip from this stream. Or, if your memory is good enough, you could remember it. But my memory's not that good, so I wouldn't trust myself.
And did you also know that purple is a lie?
What do you mean purple is a lie?
Purple doesn't exist. It's a lie. It does not exist. There is nothing in nature that emits purple light.
But the color's real.
No, it's not.
What do you mean?
It is a illusion that our brains do.
But blueberries are purple. Lavender's purple.
No, they're not. They're actually just very, very blue. But our brains trick us. Our brains lie to us and say, well, that's purple.
I'm going to need to be convinced.
Let me see if this convinces you. Inside your eye...
Isn't it magenta specifically? That's what someone in chat says.
Magenta, fuchsia, purple, violet. Yeah, it's all a lie. It's all a lie.
The purple's a lie.
Purple's a lie. It's true. And I'll tell you why. Inside your eyes, there's these clusters of cells that form these things called cones.
Yeah.
And you have three types of them. You have a cone that is the most sensitive to red light, and a cone that is most sensitive to green light,
yes,
and blue light, right?
Yes.
It's like our eyes literally have RGB baked in.
So red, green, and blue, we've got three different types of cones in our eyes.
So what happens is that between red and green, there is yellow. So when yellow light hits our eyeballs and activates those cones, the cones say, oh, this is kind of close to red light. So instead of getting really excited, being like, I'm a red cone, I'm reporting to the brain, this is red, I'm seeing red, it's great. It's like, it's kind of red, but it starts talking to the brain. It's like, yeah, kind of red. And the green cone says, it's kind of green.
Sure.
So they kind of softly activate at the same time, and then our brain says, oh, I know what to do with this. I'm going to synthesize it. That means yellow.
Okay.
When you get to blue...
So yellow, in terms of light, is red and green.
Yeah.
Sure.
Yep.
Yes.
And instead of, if you have red light, your red cone is like, oh, that's my shit. I love red. I'm really super active. Same thing with green cone. If it sees pure green light, it's like, oh, that's green cone. And it gets super energetic and sends lots of signals. If you get yellow, both of those are kind of half turned on. They're like, it's okay. Now, you get blue light, pure blue light, your blue cone is like, that's blue. I know what blue is. Sends it to your brain. Then when you get even bluer light, beyond what our brains interpret as blue, like super blue, just like infrared is kind of like super red, very, very red,
blue.
You get super blue.
Yes.
And what happens is your blue cone and your red cone, like, kind of halfsies activate.
Yeah.
So your brain says, oh, okay, this is halfway between blue and red, so it must be purple. But it's not. It's like a really blue.
Does yellow not exist?
You know, yellow exists,
Okay.
but purple doesn't.
I'm just more confused now. I'm so confused.
I'm so sorry. That's a little deviation from astronomy, but that's one of my favorite little astounding facts about life and physics is there's no such thing as purple light. There's just there's blue, and then there's like very, very, very blue. And our brains go, maybe it's halfway between blue and red. But blue and red are on like opposite sides of the visible light spectrum.
You look at this. You can see on the stream the crescent. So this is the Crescent Nebula.
That's so cool.
It's coming more and more into focus. This is 5 minutes of exposure, successful exposure. It's got a little bit of cloud cover, but whenever it doesn't have cloud cover, it detects it. But this is a far distant nebula. It is 6,000, I think, light years away, and we are able to look at it right here through the telescope. This is a live feed through the telescope right now. So this is live. This is through the telescope right now. You are seeing it as if you could see it right in the sky. You can't see it with your human eyes because your human eyes aren't good enough. That's why we have telescopes, and this is a good telescope. I like it.
I do too. I kind of want one.
It's good. I like it. They don't sell them anymore, but they've got another one, which is not bad, as far as I know. I got bumped by a bug of some sort. My eyes definitely aren't. Someone said earlier, if I'm in space, can I get a tan? Yeah.
Yeah.
Yeah. You would like burn immediately.
There's a really interesting thing that I'm trying to trace back where this came from, but most people, if you ask them, is space cold?
Yeah.
They say yes.
But it depends.
But it depends because in the vacuum of space, the concept of temperature
is a vacuum.
Doesn't really exist. I mean,
so
it does. Okay, any physicist watching this, yes.
We feel temperature
but...
because we can feel it in the air,
yeah.
And in the air is like air and oxygen and carbon dioxide and nitrogen, but of course also...
The light That's our production
over.
Light. It fell down in the wind.
I got it.
You got it?
Yeah.
Okay. That's so funny. That's it's almost like a jump scare stream.
The battery fell off. The battery fell off.
Oh no.
I got it.
You got it? Okay, great. Watch for the people tuning in that just see the red lights going back and forth. They're like, oh no! Oh no, the cops have come! I'm like, don't you take my Alistair! I will fight every last bastard!
Alrighty.
But we are fine.
Ha ha!
That is, that is funny when it turns on and just. And I think I can go a little dimmer than that too.
Nope.
Maybe not. Nope. There it is. There's a lot of atmospheric haze right now, which if we were, I don't know, shooting a Spielberg movie or a car commercial would look amazing. But if you were here right now in person, what you'd see is just because we have this little tiny light, it drowns out our vision because it's reflecting off all the little water droplets in the air right now.
Yes.
So you can see these sort of crepuscular rays, or like God rays coming off of the light. It's very glowy.
Let me see if I can make this light.
Alistair has a little laser pointer, and when you point it straight up, you can see the beam go all the way to the sky. It's very fun. It's very cool. It's a vibe. So right now we're trying to find some stable ground to so
Put
this thing
this
doesn't
tripod on.
tip over in the wind.
I feel like I need something to weigh this down.
Sandbag.
That would help.
That would help. But why? I'm sorry. Why am I suggesting something that we don't have? It's like, well, you should have brought a sandbag, Alistair.
Something for next time.
Something for next time. What a horrible thing to travel with, too.
A sandbag.
Like a 15-pound bag of sand.
Oh my God, sorry.
So I want to make sure that I don't forget that question in chat about humans visiting other star systems and other Earth-like planets in our lifetime. Well, these things are very, very far away. They're light years away, and that presents a lot of problems. And there's a handful of ideas proposed of how that might be overcome. And we're talking about very, very, very far future technology. One of those things is that, I don't know, we just figure out really good propulsion. One of the problems with that, though, is even if we have some amazing propulsion that could accelerate us up to 20% the speed of light, 30%, those kinds of very, very fast speeds, is space ain't empty between us and that planetary system. It looks empty, but there's dust and little tiny rocks. And so if your spaceship is traveling at 20% the speed of light and a microscopic rock hits it, you're talking about a impact that would be the equivalent of like the bomb that was dropped on Hiroshima.
Oh, fun.
Yeah, fun. So you die by dust. So that's not going to cut it. So you got to go slower. Well, how do you go slow when it's going to take 50,000 years?
Yeah, I'm thinking in like Star Wars light speed.
Yeah.
And in Star Wars, the most scientific media out there, they have these hyperspace lanes, which they're these areas which they know they can go straight for however long they need to go without hitting anything. Because if you hit anything going near the speed of light, you just explode and die.
Yeah.
And that could be something smaller than a pebble, like smaller than a grain of sand.
Yeah.
Because if you're going that fast, it almost doesn't matter. I want to play, like, do you know Universe Sandbox?
Yes.
Where you can, like, take, like, a tiny thing and then set its speed to a % of the speed of light and then just send it into Earth and see what happens.
Yep.
You just blow up all of Britain if you wanted to. Sorry, blow up all of France. That's something we can agree on.
As a person of German heritage, I could get on board with this plan.
Oh my
Although
God.
I must say, myself and my ancestors, we are very, we love the trees in Paris. They are quite lovely. Do you know why?
Why?
Because they're excellent shade to march under.
Oh my goodness.
Okay. By the way, contemporary Germany is very different than the American stereotype.
Yes.
It's all Germans. We're all hippies now.
We got Germans in the chat also. Haven't tuned in a long time. You're outside stargazing. How wonderful. Yes, this is a live feed of my telescope right now. Right here, you are seeing it's the Crescent Nebula, or NGC 6888. That's its scientific name. They are great at naming things, but it is slowly resolving. We are currently doing a long exposure. So the way long exposures work is you take really long pictures, and because it's a telescope, it's really zoomed in. It's a picture, you just leave the camera open for a long time, taking as much light as you possibly can, and then you save that, and then you take lots of those, and then you stack them on top of each other. So the brightest parts of them, they add and add and add and add and add and add, and then eventually, if you get enough of these captures, you can see stuff like this, which is 6,000 light years away. And those colors are real colors. So it's looking a bit like orangey red, which is really cool. I have a little NASA keychain and got my planetarium I frequent, so I can respect it. Hell yeah.
And do you know why they're orange and red?
Why?
So what are most stars made of?
Hydrogen.
Yeah, and what else?
Helium.
Yeah, you heat up hydrogen, you get kind of a red. You heat up helium, you get what?
Orange.
Yeah.
Cool.
Yep.
So wait, that's kind of reddy orange because it's like all made of hydrogen and helium?
Mm-hmm. That is a big, what you're looking at is a big cloud of hydrogen and helium dust.
That's really cool.
Yep.
So someone, can you explain telescopes? I Googled it and couldn't comprehend. So like better telescopes are just more stacks? No. So my telescope is a little tiny telescope that fits in a little tiny box. And the hole that takes in the light is like that big. But you can do long exposures, which is what we're doing at the moment, which is you have that little tiny hole and you just take lots and lots and lots of pictures with that same size, and it just adds the amount of light that it can collect. Another way of collecting more light, bigger hole. I need to come up with a better word for that. What are we doing?
Let it be known that we have shown our holes on stream tour. Well, the Twitch corpos watching this just immediately cancel the stream. Like, well, our AI detected something.
Aperture, yes. So if you have a bigger telescope with like a bigger lens, which allows you to collect more light, you can see more. And that is why they make telescopes bigger and bigger and bigger. And you see the James Webb telescope, which is in space. You like James Webb?
Yeah.
That it has
James Webb telescope is my husbando.
Tons of mirrors. And those mirrors reflect all the light into a point, and then that reflects it back into the middle of it, which is where the detector is, like the camera piece. Very, very simply put. But yes, the more light you can collect, the more stuff you can see. Or the VLT, the very large telescope, or the ELT, the extremely large telescope. And then there's even other ones, which they're like the egregiously large, I forget the exact names of them, but they're like, all right, well, we want to see more, so we're going to make an even bigger telescope. But what is bigger than very large? Extremely large. Okay, what's bigger than extremely large? And then they have to keep one-upping themselves. And they put these telescopes ideally in space, but if you're going to space, you need to put it on a rocket, and that means you can't make it too big or heavy because it's got to be on a rocket. But if you can have it on land, then it's ideally in a place where there aren't a lot of other light, because you ideally want to collect light that's only coming from space, not coming from like a city and bouncing off the clouds and bouncing off the atmosphere and like making all the stuff you see in space look blurry. So bigger telescope, bigger lens, or bigger mirrors. There's lots of different types of telescopes. There's even radio telescopes, which, I mean, maybe you can explain this better. So, like, wavelengths of light are electromagnetic radiation that we can see with our eyes because we've got special things that can see them. But like things like microwaves and infrared and radio waves are all also that. Like, there are animals which can see in infrared. We can't see in infrared. So you have really cool telescopes, which are radio telescopes, and those can see radio waves. Yeah. Coming from space.
So we can start with our beautiful rainbow again.
Yes.
We have our rainbow, and over here, on this side of the rainbow, we've got red, and then over here, we've got blue, and then past blue, there's no purple, it's a lie. And we've got just bluer and bluer and bluer.
Yes.
And as we go
That's
along
ultraviolet.
this... Yeah, exactly, ultraviolet. So electromagnetic waves also carry energy. So the more blue things get, the higher the energy.
Yeah.
So we go up the spectrum, we get to blue, we go past blue, and we get to ultraviolet. It really should be called ultra blue, because
ultra blue.
Violet is also a lie. But it gets bluer, 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 and then you go even further and you get into X-rays.
Yes.
And X-rays are amazing. And then you go even further and you get into gamma rays, and those will kill you. Yeah, they'll kill you. They will. And they have.
Yes.
They have killed humans before. Oh man. Okay, I don't want to get distracted and talking about gamma ray bursts, because I want chat to also get a good night's sleep. But gamma ray bursts are a thing. So
gamma rays are when you start to die. You are correct.
Yep. And so now let's go in the opposite direction.
That's what made the Hulk.
Yeah, which is, it's like one of those things. I don't know. Like as a physicist, when like the more you learn and then you encounter things like that in popular media, we really are very, very, very generous with media and storytelling about getting things kind of incorrect, because that's not the point of fiction. Like, fiction is meant to get to sort of deeper human truths. Yeah. But there's a certain point where it's just like you see things and it's like Stanley's like, wow, this guy, like, he's tobacco man. He smoked 100,000 cigarettes all at once and it gave him superpowers. And he's got super lungs now. And it's like, okay, so you smoke 100,000 cigarettes at once, and you have all this like horrific things happen inside you, and they're like, well, magic happened. It didn't kill you.
That way, the Demon Corps, you know about the Demon Corps.
Oh yeah, the Demon Corps. Oh,
it should have made a superhero of some sort.
Yeah,
it didn't. It just killed like everyone in the room.
It just killed people. So for those of you who don't know, at Los Alamos, when they were building the atomic bomb, you have to do this very complicated, difficult thing, which is you have to get a whole bunch of uranium of the...
We're getting very sidetracked.
Yeah, okay, let's speed it up. You have to make a bunch of really special uranium, but that's also very unstable. So they had this big sphere of uranium that they accidentally dropped, and when they did that,
this guy was playing with it with a screwdriver, and he was like, guys, look, when I kind of close it, it makes this blue light, and then his screwdriver slipped, and it closed, and it went, and it blasted them all with gamma rays.
Yep. There's a flash of light, and it's like, well, shit, everyone's dead 3 weeks later.
I think the quote was, well, that does it.
Yeah. There's what a horrible death, because it's like there's no recovery from that whatsoever, and it's like it's gonna happen over a couple of weeks.
Should we try to see if we can get Andromeda going?
Yes, we should. So going back to the spectrum, if we go now in the red direction, and we can see red visible light, And if you get even redder than that, then you get into radio waves. Lower energy, big, long wavelengths. You can also think of it as it's like bassy. Instead of being treble, it's like bassy light. And you go even more from infrared to radio waves, and you wind up in microwaves. And microwaves are these big, long things. And they're very low energy, but you can contain a bunch of them in a little box on your kitchen countertop, and you can cook your food with it. But the spectrum, the little sliver of this that we can see with our naked eye is so tiny. And when you go full spectrum, which is a glorious thing to do, I am just saying, you go full spectrum, you see so much happening in the universe. Like, just the visible light alone is like, it's fascinating.
Yeah.
But man, oh man, we put a telescope up there called Chandra that observes X-rays, and it's like, it's a whole different ballgame. James Webb is like the king of infrared. We're seeing, because
I've got something to say as well.
Yeah.
Because the universe is constantly expanding, what might be visible light gets stretched. It's called redshifting, which means stuff that was visible light a billion light years away is now probably further into like infrared.
Yep.
Lucky Charms, thank you so much for the Prime sub. I really appreciate that. Thank you. And so you have things like James Webb, which they're not designed to look at visible light. They're designed to look at like infrared and stuff that we can't see with our eyes. But because they have been stretched, it can see stuff that is really far away.
And it can see through all the dust too.
It can see through the dust. That's pretty cool. They are launching a new telescope called the Nancy Grace Roman Space Telescope, which is like a successor to Hubble. It's launching at the end of the month. I tried to go see the launch of that, and they said, sorry, we're full. So that would have been really cool. Last stream I watched before this, you were at a waterfall. I was at a waterfall. I streamed in a state park in North Carolina under a waterfall inside a cave because I could. We are in a
The stargazing was mid, but still.
No, it was during the day. I didn't have my telescope with me. But yes, we're trying to see if we can get a view of the Andromeda Galaxy right now. That is what this telescope is going to be looking at. Are we in focus? I'm not sure we are. There we go. I'm also going to go check if, oh, that's the wrong thing. I'm going to go check the battery on our internet.
Ooh, and you know what? I should go pop a new battery into the production camera.
Sure.
Because I believe it is off. So while I'm doing that,
Ooh, it's pretty cloudy.
Getting cloudy.
It's a little cloudy.
Ooh.
We got 31% battery on the internet, so we should be good.
Ooh, excellent.
These batteries are lasting longer than I anticipated, which good news.
See if I can do this without tripping over cables, which I can.
I think national parks should have astronomist park rangers for nights like meteor showers and stuff. That'd be really cool. What is really frustrating, we have a really nice camera with us today, but when we've plugged it in, so I have a camera plugged in, I have an extra monitor, I have my telescope connected, we're using satellite internet, I'm plugged into a mobile battery, my phone is connected to run the telescope. It is a bit of a mess. And when I plugged in a really nice camera that is able to see the night sky really well, because it's a really nice camera, my computer was like, it was a bit too much. And so it just crashed my whole computer. It literally, the whole thing froze. I got a thing on my screen that said, there has been a problem. And I needed to restart my computer. So if you've just gotten here, I had to restart the stream twice. But things have been working now. We've been live for over an hour and it's going fantastically. There has been a problem. No shit, really. Yes. And then it said restarting. And then it didn't restart, so I had to do it manually. Thank you again.
Alistair, could you toss me that flashlight?
This?
That one will work, thank you.
There you go. Lucky Charm, thank you for using your Prime sub, by the way. Do you know if you are a subscriber to Amazon Prime, you can connect your Amazon account to your Twitch account and subscribe for free, and it provides me the same income as if you had paid your real life hard-earned funds. And I want to do a lot more of these types of streams. I want to meet a lot more very, very smart people like Anthony.
Oh, thank you. You're too kind.
And I want to... Ooh, is it working or is it just clouds? I see a dot on there. And I want to... Why has it suddenly gone so... Why have we suddenly gone so dark? And I want to see... where'd my brain go? I want to show people the universe in ways they've never seen it before. So, oh, there we go. Fantastic.
There we go. There's your light, my dear Alistair. Thank you.
Thank you. It might have gotten too cloud. No, I can see some stars.
Yeah.
I can see some stars. Maybe we just need to be patient.
They're there. When we turned off the light and went to red light mode, it looked like I was seeing the Milky Way, but it's hard to know for certain with these sort of nighttime.
Yeah.
These little like high altitude cirrus clouds.
So what's frustrating is if the really nice camera was working, we would be able to show you the night sky, and you'd be able to see the stars and stuff. And you would maybe be able to see the, what do you call it? Maybe be able to see the meteor shower. That's the
Actually,
word.
can I see the light?
Here you go, sir.
You know what I'm going to try to do anyway?
What?
Is I'm going to see if I can just take a photo, long exposure.
Oh, not of me, okay.
And none of you.
Damn, I got posed up and everything.
You would, you'd have to sit still for 30 seconds. I don't think that's possible, Alistair.
No, I could just lay outside and look up. You could. A lot of people don't live in a city. A lot of people live in cities, so they can't see much. Alistair from Has Been Hotel. My name is Alistair. I'm named after my grandfather. He is Scottish, and it is a Scottish name. Though it is like an Englishized Scottish name. A lot of my heritage is Scottish. Being Scottish is cool. I can trace it all the way back to the islands that my heritage like clans came from. So neat, very cool. I'm Australian. I'm visiting Australia for the first time next month. I'm visiting Sydney and Perth, and I'm going to be seeing some friends while I'm there. And if I can, I'm going to try to go stargazing while I'm there, because I think that'd be really, really cool. I'm in Queensland. The Queensland. It all belongs to old Queenie. Been on a roof a lot lately. My house has roof access. I literally see nothing, just planes and buildings. Damn. You'd see a meteor shower from my state a few days ago. Yes, that was the Perseids meteor shower, which is kind of on the tail end at the moment. You generally can see shooting stars most nights, but there is a comet that's gone by, and in the tail is just a whole bunch of chunks of, I don't know, 10 to 20 meteors. And they're just, 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 they dirt and rocks and dust, and when those crash into our atmosphere, they burn up and explode, and you go, making that sound exactly. And it looks like a shooting star. And when we are passing directly through that, like the planet Earth is passing directly through the tail of that, is when you see that meteor shower. Yes.
Yeah, the Perseids are really quite incredible because until
it's
you
still
see
going
them,
on at the moment.
Yeah.
The peak was Wednesday, Thursday. It is now, well, technically it's just turned Sunday, but it was Saturday. So, and it'll be kind of ongoing until the 24th. Today is the 16th, so we've got 8 more days. You can still see some stuff. Go outside. Go touch some grass. I believe in you. I'm touching grass right now.
Grass.
Grass, yummy. There is an eclipse in February in Latin America next year. Are you going to hunt it? That would be cool. My problem is I have no money. I would love to be able to go travel. I'm going to Australia to see family, so I'm going with my family, and that's helping a lot. Yeah, I'm not sure that I'll be able to do that. Isn't there an eclipse over like Egypt or something?
Yeah, it was on Wednesday, and it went.
No. That was the eclipse over. Next year, there's an eclipse going over Egypt, I think.
Ooh.
I've seen a Planetary Society promoting that. But there was an eclipse over like Iceland and Spain, and most of Europe got to see at least a partial eclipse. I saw Phil's he's a friend. He has the same telescope, and he was able to show his stream the total eclipse, which is really, really cool. Not total. He's in England. He didn't get much, but you could still see some stuff. How seasoned are you in eclipse watching? I went to Austin in 2024, which was the last total eclipse going over the United States until 2060, or 2060 something. 2064, maybe? So maybe not for a while. But that was really cool. It was my first eclipse and maybe my last eclipse, but I might be chasing them in the near future if I can get some funds behind them, behind doing this, because I want to bring you guys to see really cool space stuff. This is a really cool camera. If I can get a better computer, then camera will work. This is a whole bunch of technical issues. And unfortunately, a lot of these technical issues come down to funding. Yes, I'm trying to do this sort of thing. I want to show you guys incredible space stuff. I want to introduce you guys to incredibly smart space people, and bring your favorite creators out to places like this, so they'll be able to see the sky and be like, holy shit, you can see everything out here. Because, you know, people live in cities and can't see anything. Working on that. Thank you, Athos. Don't worry about it.
Yeah. Okay. I'm gonna do a whole like let it go, Indiana, because I was gonna set up a long exposure so people and then we could find some way to get the photos from this to the stream, because the stars they're really, really, really beautiful tonight.
Dude, where are you? I'm in the middle of a national park in Virginia. I traveled 2 hours to get here because I was in the middle of a city. Okay, so Andromeda's not cooperating. Let's see if we could look at something else.
Okay.
Let's go see if we can see that one.
Great. All right, cool.
The
production camera's back up.
Fantastic. The way you get the best stargazing is by going to...
Yep.
Thank you kindly. might need to fix stuff. I blinded the camera.
Hey, there we go.
Lovely. Oh, they didn't like that.
Boop.
Cool.
Tracking, motion.
I'm always asleep, so I don't see stars that much. You know what? Fair. All right, so this is C12. It is the fireworks galaxy. We will see, hopefully, it will come into view. Oh, hello. Yeah, hopefully it will come into view right in the middle here. There are some dots. There's a dot right there. Oh, there we go. Okay, you can start seeing there's like a little shadow right here of light. And that should, over the course of this long exposure, should basically turn out into a galaxy.
Oh,
So
that'd be so cool.
that would be so cool. Oops, you don't want to see my Twitch stuff. There we go. Okay, so that's working. That's doing a long exposure. There are lots of galaxies out there.
Yeah, billions.
Billions.
Billions upon billions.
And in each of those galaxies, they've each got hundreds of thousands, millions, or billions of stars.
Yep. Yep.
And then each of those stars,
about
probably
400
a
billion
planet.
stars in the Milky Way.
400 billion
Yeah.
in the Milky Way.
Mm-hmm. Yeah. It's really, really, really big.
That's a lot.
Yeah.
That's a lot. That's a lot of stars. Ow. Yeah, and so in each of those stars, they probably have planets.
Mm-hmm.
Okay, there's absolutely aliens out there.
100%.
There has to
Yeah,
be.
there has to be. There has to be.
There is no chance.
Yeah.
Can you? Maybe there's another Eret. Can you collab with the extraterrestrial Eret? There's not going to be another that exact me.
Funny you say that.
Oh God.
Funny you say that. So
What are you? Okay.
Okay, so in cosmology, we have this big open question called eternal inflation, where we've worked out the theoretical physics of how this inflationary event must have happened
Yes.
in the earliest moments of the Big Bang. And what we've realized is that process that inflated our universe from a little kind of boop to a swoop.
A boop to a
A
swoop.
boop to a swoop.
Only the most scientific terms here.
More than likely had to keep on going. And if that's the case, then it leads to this consequence called a eternally inflating universe, where there's just so much universe being created. Now we don't know if this is true or not, but if it is, that would mean that somewhere out there, very, 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 very far away, there is a identical copy of our solar system with identical Earth, with a identical Alistair that lives on this Earth, and might be maybe a little different. Like,
So, in some like parallel galaxy, there could be a version of me doing a broadcast similar to this.
yes,
Looking back at us.
yes, but yeah. For other physical reasons, that message would never reach them.
Yeah, no, of course.
Because this is far past the cosmic horizon.
Yeah.
But
they're light years away.
yes.
It'll take, yeah.
Simply speaking, in mathematical terms, a eternal inflating universe, as a consequence of that, means that anything that can happen will eventually happen somewhere. And there's a friend of mine, Max Tegmark, he's a astrophysicist at MIT that actually sat down and calculated how far it would probably be away based off of the number of kind of atoms arranged in a certain way in whatever system you're looking at. And so for a human being to find an exact copy of you with all your memories and everything, we're talking just these insane
my memories
distances.
and everything. Okay,
Yes.
no. No.
Yeah.
You're not allowed to have my memories. Only I am.
Well, it's funny you say that too, because there's another concept in theoretical physics called a Boltzmann brain, which was originally proposed by the great physicist Boltzmann as a way to say, like, yeah, quantum theory is dumb and I hate it. Because if you believe quantum theory is true, then it means that there's this tiny probability that my exact brain just like pops up somewhere in space with all of my memories and just exists now somewhere in space, which is extraordinarily improbable, but it's not impossible. So a Boltzmann Alistair would be your brain with all of your memories, and it would just be you, but floating around somewhere there in space, and probably would die very quickly. But it's not impossible.
Floating in space.
Yeah.
I'm trying to adjust this to at least show that it's trying to make progress.
And these are things that we in physics think about a lot because they're very mysterious. And just because something sounds absurd as a consequence doesn't mean that the underlying physics is wrong.
Yes.
Black holes were thought to be absurd when Einstein and Rosen worked them out, and now we are like very, 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 very confident that they are real. They do exist. There is one at the center of our galaxy in the Sagittarius constellation. It's called Sag A star, and it is a supermassive black hole.
Sag. Sorry, that is. Oh, I clicked something. Oops. Hey, let me bring this over here. Thank you so much, Seraphina. 72 months. Sag is a Twitch emote.
Really?
Well, it's SADGE.
Oh.
Sagittarius. You see that? That's the emote. Is a sad Pepe the Frog.
It's like my black hole is too supermassive.
Sure.
But
I'm
yeah,
trying to click the wrong thing.
Its event horizon is I believe it would, if our sun was the supermassive black hole at the center of our galaxy, the event horizon would go out to, I think, like the orbit of Jupiter or something like that. It's really quite impressive. I don't remember the exact numbers, but it's very, very, very big.
I need to adjust some things. If I just do that, we just have the chat. That's fine. Cool.
Ooh,
So you can kind of see the galaxy is appearing in the middle. It's a little cloudy, so we're not getting a lot of successful exposures, but we are getting some. This is the C12 galaxy, the firework galaxy. It's coming into view more and more. What is the fadey thing in the middle? An entire galaxy. How far away is this? Let's see if we can see the information. Let me do some reading. You're not going to tell me? Information. It just says it's in the sky somewhere. Cool. Great. Can you look it up on your phone?
Yeah.
My phone is low on battery. C12, Fireworks Galaxy.
I'm actually really amazed that we have cell phone service out here.
Yeah.
It's like, oh, okay.
We got a little something. I've been bitten by a bug. This is the end of days. It's game over, guys. I've been bugged. Thank you again for 72 months, Seraphine. I really appreciate it. Thank you.
25.2 million light years from Earth.
25.2 million light years.
Yeah.
Okay. That is really, really, really
It's so far away.
That is so far.
Yeah.
Okay, so the light that we're seeing now is from 25.2 million years ago.
Yep.
Almost as old as your mum. No, I'm sorry. I'm sorry. I needed to come up with some sort of joke there.
Because it is a physical truth of the universe that we live in that when you look out in space,
Yes.
you are looking back in time. Even me looking at you right now is looking back in time by a tiny, 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 tiny percentage.
That is technically correct.
Yeah. And you can also look at a very, very empty patch of space.
Yes.
And you can see all the way back till about 300,000 years after the Big Bang, and you'll hit a wall there. But that's how far you can see back, is almost to the very beginning of the universe. And you can actually see, with James Webb, you can see some of the first stars that turned on in the universe. And they're long gone now.
Yeah.
But it's taken the light so long to get to us that we can still see them.
We can see so far that it's just started playing the Minecraft music. Beautiful. So we're trying to get better and better telescopes to be able to see further and further. James Webb is like the latest and greatest to be able to see like the oldest stuff.
Yep.
We can't see older than that? Question mark?
The oldest that we can see is about 300,000 years after the Big Bang, which is like a tiny amount when you think about it, because the universe has existed for 3.8 billion years. Before that,
13.8.
13.8. What did I say?
3.8.
Oh no, yeah, 13. 13.8 billion years. Before that, the universe did not exist.
Yes.
And that alone too is so mysterious and beautiful and amazing. And so we can see all the way back to its birth plus 300,000 years, and then we run into a wall. And the reason why is because if you go back in time further than that, the universe is so hot and dense that light cannot travel freely between atoms. So between material, it can't. It's
so the
light
reason
is
we
trapped
can't see
into this plasma state.
Is because light couldn't move.
Yep.
Is that why it's dark? Why isn't it like just super bright?
It's a shroud. So
what do you mean by what's that mean?
It's you can't see further back than that because it's like what you see is just like a wall of light.
Okay.
But it's also that light has been redshifted into the microwave.
Oh, so
frequencies.
We can't see it.
Correct.
Is that the cosmic background radiation?
That's it.
Like microwave background.
That's it. Yeah.
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 I know stuff. Okay, so that light.
Does.
So it is like there is light everywhere, but we just can't see it with our eyes.
It is everywhere. Yeah, that the afterglow of the Big Bang is all around us right now. Like you and me, it is in between us. It is everywhere. It is with chat. Chat is swimming in Big Bang juice right now.
So if we had special eyes that could see microwaves, the sky would be like really bright.
If you could, like, imagine if you could see microwaves the way we see color, but you could only see this very, very, very specific narrow band in the microwave frequencies, then what you would see is this. We got to find a way to show this to chat. You would see this all around us.
So this would be like, we can see the Milky Way above us. Let me pull this up.
Yeah, this is the Planck CMB. It is Papa Lima Alpha November Charlie Kilo space Charlie Mike Bravo.
Ooh, Planck.
Named after the great physicist Max Planck, where we get the, in America we call it Planck, but it's really Planck, but
okay.
This is neither here nor there. Yeah.
This.
That is
Let me-
when you look, the furthest you can look in space. So again, we're looking in space. We're looking back in time. This is the furthest we can see.
So if you could see microwaves of your eyes, this is what you'd see.
Yep. And again, this is a very, very small frequency band.
Yeah.
So it's not all microwaves, but a very specific band of microwaves. This is what you would see. So what we're looking at here, this is a baby picture of the universe.
Cool.
This is what the universe looked like about 300,000 years after its birth.
That's so cool.
Yep. And all of those little differences in color that you see are tiny, 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 tiny differences in temperature.
So the red area is where there's like more stuff, and the blue area is where there's less stuff. There's differences in temperature. You said.
Yeah.
Okay.
The other way around.
Oh, so there's more stuff in blue.
Blue is more energy. Red is lower energy. Blue is hotter.
Oh, yes.
Yeah.
Blue is higher frequency than red. I'm used to red being hot and blue being cold.
This is one of the things that happens to you when you start getting a physics education. Like you,
And
your
purple is
your,
fake.
Yeah, purple's fake. So when I started studying physics, it unfortunately awakens your inner Redditor moderator, like your inner like Reddit moderator thing. So when someone says like, oh, it's glowing, like it's so hot, it's glowing red hot, and I'm like,
Well, actually, like if you said it was glowing blue hot, that would be more accurate to the physics. But
Oh my god.
that is to say, of course, blue things are hot.
That's cool. That's really cool. Awesome.
yeah,
That's actually
and this is what really blows our minds as physicists about this this image. The cosmic microwave background radiation is our best theory of how matter works. We call it the standard model, or the standard model of particle physics, if you want to be more precise. And we could just call it quantum theory. It predicts those little differences. Like our physics predicts that. So that
we could just like math it out, and we would come out with that.
Yeah, that tells us that the Big Bang was a quantum event. That quantum theory did its little quantum-y things during the birth of the universe, and that's what led to that, because it perfectly predicts it. It's so cool.
But isn't it like kind of like random noise though, or like?
So that's the thing is it's if you have a thing in the universe that is like perfectly uniform,
Sure.
then what is causing it to kind of get a little bit random? And the thing that's doing that are these quantum effects that happen during the inflationary event. Right after the Big Bang, there's like for a trillionth of a trillionth of a trillionth of a second, there's that swoop moment, that's where the little quantum fluctuations happen that lead to
Is that what entropy is, or is that something just completely different?
Entropy is a related concept.
Okay.
But it's entropy is a very important concept in how we understand the thermodynamics of systems. So which is just another way of saying of how stuff kind of arranges itself.
Okay.
It's often misquoted as entropy is like a measurement of chaos, but it's not. It's it is a way of understanding the arrangement of objects in a thermal system as mathematical quantities, and that has very useful applications.
Cool.
So the second law of thermodynamics is that entropy is always increasing for a closed system. We don't know if the universe is a closed system or not. It could be or it could not be, but either way, that's very mysterious, because if it is a closed system, then we get a picture of like the fate of the universe where
When you say a closed system, what do you mean? Like, there are other universes, or do you mean like if the universe dies, then it'll happen again?
A closed system would be one in which energy can neither be injected into the system or could ever leave that system.
So we don't know if the universe could get more energy at some point.
Correct.
But if it can't get more energy, then it will just eventually spread out, and that's what heat death of the universe is.
Yes. So we know the universe is expanding.
Yes.
We discovered this other amazing thing about 10, 20 years ago. Maybe more like 20. There's a colleague of mine, Saul Permuter, that won his Nobel Prize for this, actually. And what we've discovered is that not only is the universe expanding, that rate of expansion is increasing. So it expands, and then it expands faster, then it expands faster, 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 faster.
I would assume it'd be slowing. No, because of course, object in motion stays in motion. But why would it be getting faster?
We don't know.
We don't know?
No, but we know that it has to do with the stuff called dark energy.
We need to do more science, guys. Get on it now.
Chat, please figure out dark energy and tell me.
Chat, just solve quantum physics for us, please.
Yeah. It would help me. It would help us a lot.
Science man, how many quarks are there?
So there's quarks. What's interesting about quarks is there's technically kind of, a quark is a quark, but they come in different flavors. So we have red quarks, green quarks, blue quarks, and because of that, the nuclear physics has a technical name. It's called quantum chromodynamics, and quantum chromodynamics. Chroma from the Greek word for color.
So quarks make up protons and neutrons and stuff.
Yep.
Oh God, I'm remembering all my physics education. Fuck, there's up quarks, down quarks, strange quarks. Like literally, that's the name.
You
of
forgot.
some of
You
them.
forgot. You forgot the silly ones. There's two other flavors of quarks.
Yeah.
They're sort of their quark personality. So we have a up quark, down quark.
Yeah.
Charmed quark, strange quark.
Yeah.
And you're gonna love this. Top quark, bottom quark.
Interesting.
Yep.
I'm actually planning on studying quantum physics. You shall solve the problem.
Nice. Oh,
Good luck, soldier.
It's so good. It's so good. And people say all the time, they're like,
top and bottom, I know those ones.
Yeah. The amazing thing about quantum mechanics is I want to encourage everybody to not be scared of it, because it's talked about. Like, a lot of physics is talked about like it's inaccessible. Like, people say like, oh, I mean, you should, Alistair, you should do this thing. It's not rocket science. It's like, rocket science isn't that hard. Rocket engineering is really hard. Rocket science is kind of easy. Quantum science is not as hard as people would expect. It gets very technical, and the technical aspects and the math can get really like daunting, but it's all very, very, like, it's very logical. You just have to learn it. Like, it's and that takes time. It's like learning a language.
And it's easy.
Well, figuring out new stuff is hard. Like, I mean, yeah, that's why, if I ever won an Emmy, people would be like, wow, that must be so hard and challenging. It was like, oh, you think this is hard? You should try quantum theory. Meh.
Physics explained by the right teacher is the most fascinating. You taught physics for a while, right?
Yeah.
You've taught some really cool people physics as well.
Yeah, I can't.
You can't disclose.
I can't disclose without violating some really scary NDAs.
Yes.
But some of my students, chat, are probably fans of.
He knows his stuff. And that's why you're here.
Yeah.
To answer your questions. Okay.
I also have I have some amazing Stephen Hawking stories that I still got to wait a couple of decades, because your country's most famous physicist, besides Isaac Newton, is the greatest physicist of all time. Stephen Hawking is he is a charmer, and he is very adventurous, and I've gotten into some misadventures with him, like that I can't talk about, but I'll just say, physicists are amazing people because they're on the road a lot, and they're kind of like rock stars in a sense of I won't name any names, but I've had a lot of fun adventures with your classic rock star stuff of like sex, drugs, rock and roll.
With physics nerds.
Yeah, with physicists.
Sure.
Yeah,
Interesting.
it's great. Yeah, there's one night where I ended up at a discotheque, drunk with a bunch of physics colleagues, including there was 2 Nobel Prize winners, and these granted, they're all very, very, very older than me.
Yeah.
But we're just like cutting it up on the dance floor, and this was the genius.
I wish I could see what sort of dance moves a Nobel laureate.
I won't name names, but I'll show you a picture. But one name I will drop though is there's
Getting physical with physicists.
Yeah, hey, there's a colleague and a really, really dear friend of mine named Katie Freese, who, if James Webb discovers these objects called dark stars, they're early stars that are made out of dark matter, then she's just instant shoo-in for the Nobel Prize. She's one of the I think she's the department chair. She's one of the big physicists at UT Austin.
Yeah.
She's a total gem, and her conferences are the absolute best because she's the one who's like, it's up to the conference organizer to plan the activities. And Katie's the type of girl who's like, we're all going dancing, like drink up, like, and
being social is not just for like people who don't know smart stuff. I guess that's good. That's cool.
Yeah. It's a beautiful world, and having science with us as a human species, I think is an absolute gift, because there's another colleague of mine who I went to a talk once with. It was a public talk, and he said this thing that really hit me that I just thought was so beautiful. Is like, why we do science is that it's the only thing that all of us as the human species own together. Because once we learn things,
this the most collaborative thing.
Yeah.
You add it to the collective knowledge of the human race, put it on the internet, and then it's like, all right, we have another block on the Tower of, I don't want to use a biblical analogy, on like the Tower of Babel of like all of human knowledge, and we can solve all the problems. Yeah. Hopefully. We'll see.
I mean,
there's some stuff that's just like faster light travel. Maybe never, but maybe. Maybe.
Do you know where the word comes from? Science?
Where does the word science come from?
It's Latin. It comes from scienta,
Yeah.
which literally means to know. That's it.
Cool.
Science is the process of how we learn things, how we skeptically interrogate the world that we live in, how we know to know and how to know things, and how to like know how well we know things. It's just to know. That's it.
Neat. I think the battery's died. So we are going to focus on wrapping up, I think. I wanted to ask you what your necklace was, because you said you would talk about it on the stream. It's a little jar with a little bit of like powdery dust in it.
So this is the thing I got. This is one of the most sacred things I have in my life, and it's a little piece of dust that came from the Black Rock desert playa in Nevada, where every year there's this big sort of festival called Burning Man.
Oh, cool.
Now, it's hard to describe exactly what Burning Man is if you've never been, because most people think it's kind of like a Coachella-esque thing. It's not.
But it's not a music festival.
It can be parts of it. Really what it is it's a city.
Sure.
And it's also an art project. But there's this very important thing that happens at Burning Man.
Yeah.
Where every year there is there's this beautiful building that's created that's called the Temple.
Sure.
It's all made out of wood. And when you're at Burning Man, you go to the temple to take things from your life that you need to let go of.
Yeah.
And then it Burning Man is many things, and then on the final Saturday, like the big wooden man burns. It does what it says on the tin. But something very special happens on Sunday, which is the true last day, which is the temple burns.
Yeah.
And so you go there and to bring the things that you need to let go of. And then on Sunday night, there's you surrounded by 30 to 40,000 people in silence.
Yeah.
And 30 to 40,000 humans in silence encircling this building that's on fire is an incredible experience. But when I went to the temple, this thing had happened in my life where I met this girl who I was the love of my life, and we were engaged to be married. And I came home one day, and her bags were packed. And she just said, "I'm so sorry. I'm such a horrible human. You deserve somebody better than me. I'm calling things off. I'm leaving." And I'm like, "What the fuck?" And many tears. And this was all such a blur.
Sure.
2 hours later, she was gone. I never saw her again in my life. And this absolutely destroyed me. It really destroyed me. And so I had this photo of her and me with my family that meant the world to me, and it was sort of the last piece of moving on from my life. And I remember going into the temple at Burning Man, and what you're met with is you're surrounded by photos of all these people who were loved, people who were cherished, and there's letters and there's notes, and it's so overwhelming, and you feel like you're sharing like your loss with everybody else's, and there's people in there that are going through the mourning processes just as you are. And I just broke down. Yeah. And I'm on the floor just a wreck, saying goodbye for realsies to the person who meant more than anything to me in my life, who I loved so deeply. And this woman, I still to this day I have no idea who her name was, but she put a little piece of that dust that was all around us on this floor that I was on, and she held me for, God, it must have been like a half hour.
Oh wow!
She just held me and put a little dust in this jar and handed it to me, and said, "This is for you. When you're ever feeling lonely, to remind you of us, and we were here." And then that Sunday night, temple burned. And something that I would love to give to chat is just this little thought that I hope when you have a chance to look at the stars in this amazing universe that we live in, and look at this beautiful little speck of dust that we all live on, and we have this beautiful little moment of this mysterious consciousness in life that we have, that you remember that we were all here together, all of us, on a little bit of dust.
We are so lucky to be able to observe and experience the world around us, and be able to look up, like even 100 years ago you couldn't see this.
Yeah.
And now it's accessible to theoretically anyone.
Yeah.
And you get to experience the beauty and the wonder and develop further understanding of just how amazing but also logical our universe is.
Yeah.
And we're putting it together, and we're understanding more and more, and it's beautiful.
And I would say
So vast.
I would say to chat, if
A lot of hearts in chat.
space. Oh, thank you guys. If space and the universe make you feel small and alone, it shouldn't. If anything, it should make you feel big, tall, and connected to everything, because this is what we're all made of. This is where we all come from, and all of us, every single human being, we're all here together.
The atoms that make up your body were once in the center of a star. Well, maybe not the center, but inside a star.
Yeah.
That exploded, and it all coalesced into the planets and our sun and everything, and has evolved into the plants, evolved into our ancestors, and is now us.
Yeah.
It's cool.
You're not alone.